Hello. In this video we will introduce you in how to use simple supports twin load, shear moment, and deflection of beams calculator in Mechanical Engineer Partnership website. In the menu bar choose calculators and then choose shear moment and deflection of beams, and then choose simple supports twin load unit. All studies, materials, and formulas used in these calculation sheets are in reference with Mechanical Engineering Design, Book 7th edition, by Joseph E. Shigley 2004. In the left side is data, metric and imperial units, and in blue color, we obtain the results in metric units respectively imperial units. Data are the length of the beam L, in meters, or inch, twin forces F, in Newton, or pound force, a distance of F force in meters or inches, x, distance in meters, or inches. In this calculation we have, z-axis perpendicular on xy plan. Module of elasticity E in gigapascal or psi, the second moment of area in this case is in centimeter to the fourth power or inch to the fourth power. Figure shows a beam simply supported by reaction R1 and R2 and loaded by two F forces located at a distance ends of beam. If the beam is cut at some section located at X and the left-hand portion is removed as a free body, an internal shear force V and bending moment M must act on the cut surface to ensure equilibrium. The shear force is obtained by summing the forces on the isolated section. The bending moment is the sum of the moments of the forces to the left of the section taken about an axis through the isolated section. The sign conventions used for bending moment and shear forces are, clockwise for positive moments and counterclockwise for negative moments. Positive shear forces in the same direction as y-axis in the figure and negative shear forces for opposite orientation. Analyzing the graphic we observe, the shear forces are maximums on the extremities, over a distance, positive in left and negative in right. In the middle of beam over L2 a distance, shear force is 0. Bending moment is positive and maximum in the middle of beam over L2 a distance, and 0 in extremities. The results are, force reaction of the A support R1, moment reaction of the A support M1. Force reaction of the D support R2, moment reaction of the D support M2, shear force in beam at X distance Vx, bending moment in beam at X distance Mx, deflection of beam at X distance X, maximum bending moment in beam max, maximum deflection of beam Mmax, maximum shear force in beam V. Maximum bending moment in beam max and maximum shear force in beam V are used in calculation of normal and shear stresses. See the pages with stress calculators. Initial data in International System Unit in left side have equivalent data in Imperial System Unit in the right, but the two blocks work independently. Let's have an example in metric, 3 meters for the length of the beam, 2000 newtons for F force, a distance 1 meter, and then, 1.5 meters for X distance, in the middle of beam, module of elasticity 205 gigapascal for second moment of area. If you have already the value, write it in correspondent cellule, in centimeter to the fourth power. If not, choose calculators and then area moment of inertia, choose your beam section, for example, an I section, choose area moment of inertia about X. Axis 9, in this specific case, copy the value and return to simple supports twin load, shear moment, and deflection of beam, calculator, paste the value of area moment of inertia, in second moment of area is cellule, replace the length L, 3 meters, 2000 newtons for F forces, and 1 meter for a distance, and then, 1.5 meters for X distance, in the middle of the beam, module of elasticity 205 gigapascal, and then, calculate. The results are in the blue table, because we choose X distance 1.5 meters in the middle of the beam. The deflection of beam at X distance X and maximum deflection of beam Mmax have same value. Maximus value of shear, bending moment, and deflection are generally used for dimensioning a beam. Similar calculation in imperial units, data, and results. At the bottom you can use the buttons to update, refresh, print or submit. You can print or save PDF file your calculation. For quality of your work, use these calculator sheets for verification complementary with other calculators, or methods like finite element, and to find these geometrical properties. Thank you. And see the other videos with explanations about beam's deflection, area moment of inertia and the calculation of stress.